Good evening, this is V. Sujit Babu from ECB section. Today my topic is about terrestrial television broadcasting of audio-visual content from communication systems. Introduction to terrestrial TV broadcasting. Terrestrial TV broadcasting delivers audio-visual contents over radio waves from ground-based transmitters to antennas at viewers' home. It remains widely accessible medium, especially in rural areas where internet or satellite infrastructure is limited. The system uses designed frequency bands in the VHF and UHF spectrum to transmit analog or digital signals. Unlike streaming, terrestrial TV offers free-to-air reception without subscription fees, promoting broad public access. This course module covers the technique principles, signal processing, and transmission standards used in modern terrestrial TV systems. Historical evolution of TV broadcasting. Mechanical televisions made in 1920s used in rotating disc to scan the transmit images and pointed by invention like John Logue Brad. The shift of electronic television in the 1930s using cathode ray tube CRTs enabled higher resolution and real-time broadcasting. Analog color television standards such as NTSC, PAL, and SCCAM were introduced in the mid 20th century to support color transmission. The transition from analog to digital broadcasting began in 1990s, improving signal quality and spectrum efficiency. Countries worldwide have complete are in the process of switching analog signals to in favor to the signal of digital terrestrial televisions DTT frequency bands and spectrum allocation. Terrestrial TVs operates in the VHF 30 to 300 MHz and UHF 30 to 300 to 3000 MHz bands with specifically channels assigned by regulatory bodies like FCC or ITU. VHF bands offer better propagation over the long distance and through obstacles, but the support lower bandwidth. UHF allow higher data rates and similar antennas, but more susceptibility to signal blockage by buildings. Each channel allows higher data rates and similar antennas, but are more susceptibility to signal blockage by building. Each TV channel occupies 6, 7, or 8 MHz bandwidth depending upon regional standards. Spectrum planning ensures the minimal interface between adjacent channels and neighboring countries through international coordination. Analog versus digital terrestrial. Analog TV transmits continuous waveforms for video and audio, making it vulnerable to noise, multipath distortion, and signal degradation. Signal TV converts audio-visual content into binary data, enabling error correction and compression and resistance to interface. Digital systems support multiple per channel using statistically multiplying the increasing channel capacity. Viewers request to set-top boxes or digitally ready TVs to decode the digital signals, where analog TVs can receive older signals directly. The digital switchover improve picture quality, enable interactive services, and free, freed up with spectrum for mobile broadcast. Digital terrestrial standards. DTT systems uses standardized modulation and coding schemes to ensure compatibility across regions and devices. ATSC employs 8 VSB modulation for robust terrestrial transmission in 6 MHz channel. DVB-T used in Europe, Africa, and parts of Asia uses COFD coded orthogonal frequency division multiplexing to resist multipath interference. ISDBT used in Japan and some parts of South America. supports hierarchical transmission and mobile reception via segment OFDM. Each standards includes specification of video compression and audio coding and service information signaling signal modulation techniques in DTT. Modulation encodes the digital data onto a high frequency carrier wave for transmission over the air. QAM QAM is used in cable TVs, but terrestrial systems prefer more robust and schemes due to channel impairments. CYFDM divides the signal into many parts, narrow subcarriages, each modulated with QPSK or 16 QAM to compact frequency selective fading. Guard intervals between OFDM symbols to reduce inter-symbol interference caused by multipath propagation. Higher order modulations increase data rate but require better signal to noise ratio, limiting coverage range. Video and audio compression in broadcasting. Raw video and audio data in too large efficient transmission necessitating before the broadcasting. MPEG2 was standard for early digital TV, supporting standard definition videos with moderate compression efficiency. H264 AVC AVC offers the better compression, enabling high definition video within the same bandwidth. H265 HEVC further improves the efficiency, allowing 4K UHD transmission through adaptation in DTT is still limited. Audio is typically compressed using MPEG1 layer 2 AAC or AAC3 codes to deliver stereotype or surround sounds with low bitrate. Broadcasting transmitters are located on tall towers on terrain, maximizing the line side coverage over large areas. High power amplifiers boost the signals to levels ranging from hundreds of watts to several kilowatts depending on the coverage needs. Transmitting antennas are designed for wide horizontal coverage and specific polarization, usually horizontal or circular. Gap filters or repeaters are used in shadowed areas to rebroadcast signals and improve reception. Network planning tools like simulate coverage, interference, and signal strength to optimize transmit placements and power settings. Multipath propagation. Multipath occurs when signal reflects off building sills or other obstacles arriving at the receivers at different times. This causes ghosting in analog TVs and inter-symbol and interference in digital systems, degrading picture quality. CYFDMs in DVM TV mitigates multipath by using a long symbol duration and guard intervals to observe daily spread. Receiver equalizers adaptively and compensate for channel distortion and improving demodulation accuracy in challenging environments. Urban areas with the tall buildings and pose greater multiple challenges than open rural regions and requires careful system designs. error correction and signal robustness. As digital TV systems use forward error correction to detect the correct bit errors caused by noise and interference. Correlational coding combined with Reed-Solomon coding provides strong protection against the burst errors. The code rate is 1 by 2, 2 by 3, 3 by 4 determines the trade-off between error resistance and data throughout. Hierarchical modulations allow stimulation, transmission, and robust and high quality rate streams for different receivers. Link adoption techniques adjust modulation and coding based on channels conditions to maintain service continuity. The receiver designs and set-top boxes. TV receiver demodulation RF signals decode the signal stream and decompress the audio video for display. Tuner circuits, select the desired channel and convert into an intermediate frequency for processing. Demodulators extract the digital bit stream and using techniques like VSB or COFDM depending on the standards. Setup boxes includes decoders for video, H264 and AACs and conditional access for encrypted services. Moderate receiver supports electronic programs, guides and EPG interactive applications and time shifted viewing via building in storage. Spectrum efficiency and channel sharing. Digital broadcasting allows multiple TV programs to share a single 68 MHz channel using statistical multiplexing. A typical DVB-T multiplexing can carry 4 to 6 standard definitions SD or 2 to 3 high definition HD channels. Variable bitrate and encoding allocates more bitrates to complex and scenes fewer. Static ones optimizing bandwidth usage. Signal frequency networks enables multiple transmission to broadcast the same signal on the same frequency, improving coverage. SFNS requires precise time synchronization to avoid self-interference between transmitters. Future trends and transition challenges. The future EATSC 3 next gen TV supports 4K HD, HDR, immersive audio, and internet integration for hybrid broadband services. Mobile TV reception is being enhanced to support smartphones and tablets using layered division multiplexing LDN. Spectrum reallocation for 5G reduced available TV bands, promoting broadcasters to optimize usage or share spectrum. Public awareness campaigns are essential during the unlock switch out to ensure viewers upgrade equipment and avoid service loss. Despite of streaming growth, terrestrial TV remains vital for emergency alerts and public services, broadcasting and universal access. Thank you.